table is basically a bunch of random elements thrown down on a piece of paper in a specific order. However, the periodic table is comprised of the knowledge and findings of many scientists. You got Aristotle, Johann Wolfgang Dobrinner, John Newlands, Dmitri Mendeleev, who created the first periodic table by mass, and more illustrious names. And pretty much that's the history for you. Also, let's learn about the periodic table itself now. If you take a look at the periodic table, you'll see there's columns and rows. The rows are called periods, and the columns are called families. Because the elements are ordered by atomic number, the elements fall into groups and then have similar properties. Families 1A through 7A are representative elements. Transition elements 1B to 12B and energy transitions are the bottom two rows. Nonmetals are on the right side of the metalloid line. All nonmetals are gases at room temperature except for bromine and iodine. They are dull and brittle and poor conductors of electricity. Metalloids have properties of both elements. They are semiconductors of electricity. And an example of metalloids in the real world are silicon and germanium. They are used throughout computers and many different uses. Now, metals are solid at room temperature. They're glossy, excellent at conducting electricity, and are malleable and ductile. Also, we have a periodic song to help you remember your periodic trends. And now, here's Dan to do experiments with metals and nonmetals.
Now let's see what happens when we mix nonmetals, or gases, with metals. Now, you see this, all this, that's air. And this here, that's metal, or an alloy solution, which is basically a mix of different types of metals. Now let's see this reaction. Safety first. Let's see this. Wow, look at that explosion. You didn't see anything? That's right, you didn't see anything. Actually, what happened there was rust. And if you take a look, as the oxygen bonds with the iron, it makes iron oxide, which is rust. The iron turns orange. I mean, come take a close look at that. I mean, can't you see that right there? And right there? And right there? Wow! That's some serious chemistry right there. This here's the periodic table of elements. Right here. It's really small over here. But as we move across the periodic table, it gets bigger. Right here. So I'll show you that again. Small. Big. Small. Big. Small. Big. Ionization energy. Over here in the bottom right, it starts off small. But as we move up towards helium, it gets bigger. Here. Smaller. Here. Bigger. Over here. Ionization energy. Electronegativity. It starts off small. Here. And then it gets bigger as we move to fluorine. Not helium. Fluorine. Not helium. There's almost no reactivity over here. None. Noble gases. They're not reactive. They're failed. No reactivity. It's very small. But then we move back here. And it's really, really high. Reactivity speaking. We have an experiment. Kind of. For you coming up. The Mentos are francium, okay? And now the Coke is just water. Let's see how this works here. Wow, look at that reaction! Now, you see, the francium reacted with the water, and it created a very cool reaction there. Go science! Now let's see what happens when we mix non-metal, this is or an alloy me. React to, it's a dog! Here!